Jamal is researching the characteristics of a car that might be useful in predicting the fuel consumption rate, FCR. That is, the number of gallons of gasoline that the car requires to travel 100 miles under conditions of typical city driving. The length of a car is one explanatory variable that can be used to predict FCR. Graph I is a scatter plot showing the lengths of 66 cars plotted with the corresponding FCR. One point on the graph is labeled A. Jamal examined the scatter plot and determined that a linear model could be a reasonable way to express the relationship between FCR and length. A computed output for a linear regression is shown below. A. The point on the graph labeled A represents one car of length 175 inches and FCR of 5.88. Calculate and interpret the residual for the car relative to the least squares regression line. By definition, a residual is the difference between the y-value of the data point and the y-value of the point on the least squares line with the same x-value as the data point. Then, using the equation given for FCR and the value 175 inches for the length, the predicted FCR value is approximately 4.93 gallons per 100 miles. The residual will be then the difference 588 minus 4.93 equals 0.96 gallons per 100 miles. The positive residual value means that the real value is greater than the predicted value. This means that the real car's FCR is about 1 gallon per 100 miles greater than the FCR predicted by the linear correlation obtained by Jamal for his 66 FCR measurements. Jamal knows that it is possible to predict a response variable using more than one explanatory variable. He wants to see if he can improve the original model of predicting FCR from length by including a second explanatory variable in addition to length. He is considering including engine size in liters or wheelbase, the length between axles in inches. Graph 2 is a scatter plot showing the engine size of the 66 cars plotted with the corresponding residuals from the regression of FCR on length. Graph 3 is a scatter plot showing the wheelbase of the 66 cars plotted with the corresponding residuals from the regression of FCR on length. B. In graph 2, the point labeled A corresponds to the same car whose point was labeled A in graph 1. The measurements for the car represented by point A are given below. I. Circle the point on graph 3 that corresponds to the car represented by point A on graphs 1 and 2. I. There is a point on graph 3 labeled B. It is very close to the horizontal line at 0. What does that indicate about the FCR of the car represented by point B? To answer these questions, we have to consider first that point A has the next values. In graph 3 are plotted residuals versus wheelbase. Then it's necessary to locate the point with values 93,098. To answer the second question, we have to consider that point B has a residual value very close to 0, which means that the FCR value predicted by the correlation line FCR car length is very close to the real FCR value measured for this car. C. Write a few sentences to compare the association between the variables in graph 2 with the association between the variables in graph 3. To answer this question, we have to observe that in graph 2, residual seems to have a moderate positive linear correlation, which means that the difference between real FCR and predicted FCR increases as the car's engine size increases. In graph 3, residuals look like a cloud, with a possible but very weak positive correlation, which means that there is not a strong change in the difference between real FCR and predicted FCR because an increasing or decreasing of the car's wheelbase length. B. Jamal wants to predict FCR using length and one of the other variables, engine size or wheelbase. Based on your response to part Z, which variable, engine size or wheelbase, should Jamal use in addition to length if he wants to improve the prediction? Explain why you choose that variable. To answer this question, we have to compare graphs 2 and 3. We can see that points in graph 3 are more spread than points in graph 2. Because there is a stronger correlation between residuals and engine size, then engine size can be used as an additional variable to explain better the unexplained variation between real FCRs and predicted FCRs.